Water, also known as H2O, is an incredibly fundamental thing for life to exist on planet Earth. H2O, it's an incredibly special molecule. Water is very, very special. The way that it bonds not only between itself, but between other water molecules is incredibly special and is the reason that life exists on Earth. Water is an H bonded to an O, then which is also bonded to an H. Hydrogens can only bond once each, and oxygens in them, I think basically in every single case, can only bond twice, and that's the sort of maximum thing. They can bond to things once, but that will mean that they are either radicalized or have a negative charge, and something being a free radical is not a good sign because they're very reactive, and they're the things that kind of cause you to age and cause oxidative stress and stuff like that. But despite its covalent bonds between the molecules that exist inside of one water molecule, there is also something known as hydrogen bonding that exists between each different sort of molecule of water. When you have a hydrogen that is bonded to an electronegative atom, such as nitrogen, oxygen, or fluorine, in this case with water it is oxygen, you have the H's bonded to the oxygen inside of a water molecule. This H that is so electron deprived because it is bonded to a very electronegative atom which is pulling the electron pair inside of the covalent bond towards it, it's going to almost try to physically bond to a lone pair that is on another oxygen atom inside of the water molecule. Oxygens, because they can only bond twice because they only have two unpaired electrons, they have two lone pairs, and so a hydrogen is going to try to physically bond to one of these lone pairs, and it's going to mean that the forces of the world, such as heat and pressure, it's going to take a lot more of that to be able to break these bonds to make water turn into a gas. There are gases such as methane and hydrogen sulfide. None of these things, carbon or sulfur, can hydrogen bond, and so that means that they have boiling points that are in the negative, triple figures, like negative 160 or negative 125, something like that. Water has a boiling point of 100 degrees Celsius. It's not in the negatives, it's not even in the double figures, it's in the positive triple figures, which is an incredibly rare thing for a molecule of that molecular weight. But because water is so special, because it can hydrogen bond, as well as something like ammonia, for instance, but ammonia is weaker than water because it only has one lone pair rather than two like oxygen does. That does mean that at room temperature and human body temperature, water is a liquid, which is fundamental for not only human life, but life on Earth as well. The whole centigrade scale is based off of water's freezing and boiling points. It's not a coincidence that water's freezing point is 0. That's because they kind of set it like that. It's not a coincidence that it's 100. They just sort of set the intervals in how hot something gets to be able to mean that when water boils it's at 100. So that's another interesting fact that you may not know, because I think I did used to think that it was a coincidence when I was a little kid, but they're the kind of things that you just think when you're a child, I guess. But even though water has separate freezing/melting and boiling/condensation points at 0 and 100 respectively, water can exist in all three states at the same time. You look at Antarctica. How is it possible that there is ice next to water, despite the fact that the temperature in that area is going to be exactly the same, yet they're in two different states? One's either got to be freezing imminently or one's got to be melting imminently, because there isn't supposed to be a way that ice can exist above 0 degrees without it starting to melt, and there is no way that water can exist below 0 degrees without it starting to freeze. So that doesn't make much sense. But then you've also got the gaseous version, water vapor. How on earth can water vapor exist at 0 degrees Celsius? That seems to not make much sense, right? But if you think about it, you would have seen water evaporate out of puddles. You look at a puddle on a path in your road or something, that puddle's going to be gone in a couple of hours because it's going to evaporate. It doesn't need 100 degrees Celsius to boil. It just needs to evaporate to have at least enough energy to turn very, very slowly into a gaseous state. But there's a difference between evaporation and boiling. I think boiling points is different, but evaporation is like a whole different process entirely. I'm not actually quite sure how that works chemically, but for water there is a thing known as a triple point where all three states can exist at the same time, where it's the pressure also has an effect on how these molecules interact, as well as the temperature. I think the triple point is 0.01 degrees Celsius and 4.8 kilopascals. I don't know. That's a complete guess, but there's an image up on screen which will show you what I mean, and hopefully you understand that a little bit better. As well as water being an incredibly cool physical molecule, it's also very useful chemically. It can be used for hydrolyzation reactions, which is useful not only inside of the body but in organic chemistry as well. Hydrolyzation reactions are used to break down starches and complex carbohydrates as well as proteins as well. But not only is it useful in chemical reactions, it's also quite useful as a solvent. A solvent is something that dissolves another organic molecule. For instance, ethanol. Ethanol dissolves very easily in water because it is able to hydrogen bond with the water because it has the O and the H. That enables, that fills out the requirements for hydrogen bonding, and so it's able to sort of dissolve and mix with the water molecules. Something like oil, however, cannot hydrogen bond, so it's not able to mix. Like ethane, I mean, even though it's a gas at room temperature, it won't mix. Pentane, which is a liquid at room temperature, won't mix with water whatsoever. And even longer chain alcohols such as butanol, pentanol, hexanol, they won't mix with water because even though it can hydrogen bond, the carbon chain is just too long for it to be able to mix. And that's the same thing with fatty acids as well. Fatty acids like oleic acid, olive oil, even though olive oil isn't actually oil such as crude oil, it's not derived from that kind of thing, it's still not able to mix with water because the hydrocarbon chains are just so long. And even though it can hydrogen bond, it's not enough to be able to make them mix. So while it can be a good solvent, it can only be really a good solvent with things that are able to hydrogen bond, and that means that it can mix. Now, apart from all the scientific uses of water, it is a very useful thing for you to drink on a regular basis. I used to just not drink enough water straight up because I never used to have a water bottle, and if I did, I would lose it pretty much immediately because I was just I was just that kind of child in a weird sort of way. Now I do keep my water bottles a lot more closer to me and I take a lot more care of them so that I can actually have drinks inside of school, and I won't go like an entire 6 hours without drinking any straight up water. And while there is water inside of the foods that you eat, the apple, the orange, and stuff like that, there's a lot of water inside of there. It's not going to be enough to sort of keep you going, and you do need sufficient amounts of water, especially when exercising, to actually keep you going. I used to just not exercise that much anyway, so I really wouldn't drink that much water. And even if I was playing a football match or I was running or something like that, I just wouldn't drink that much water because I would just firm it if I forgot it, because most of the time it would be the cause that I forgot it that would be the reason that I didn't drink. And yeah, that was just a very stupid part of my life, I guess. But now I drink a lot more water than I used to, and I'm getting quite thirsty now, so I've been recording quite a lot for the past hour. But I have a water bottle down here where my bag is, so that means that once this video is finished recording, I'll actually be able to recuperate and have a drink of water. But as much to people like me, it's a very useful thing in science, which is something that I enjoy. It is very useful for you in terms of your health. It will stop you from being so stressed. When I went through a time in my life when I was quite stressed, even though I didn't really have that much to be stressed about, I have more to be stressed about now, even though I'm really not that stressed at all. I wasn't drinking much water. I was doing the things where I was saying earlier, I was forgetting to drink it, and I wasn't bringing it to school. I wasn't having it when I was doing physical activity, and I do that all now, and I'm not as much stressed. And this has been backed up by many scientific studies and stuff like that. It's just a very, very useful thing, and it's going to help increase your performance because water is involved in loads of biochemical reactions in the body. Your body's made up of like 70% water. A lot of your cells and a lot of their structures are going to be made from water. So it's a very useful thing you just need it, essentially. So what can you take away from this video? You now know a lot about water than what you didn't before, some cool facts and etc. to impress people and increase your scientific knowledge. And now you just know to drink water because it's just an incredibly important thing, has many benefits, reduce stress, increase your performance in physical activity, and loads of other stuff that it's going to take me a while to explain as well. But with that, I recommend subscribing because I love this community of young trouble people who are willing to improve themselves so much more than you already have, and good luck.